So in this first lecture, we will start with basically functions and graphs. So basically from the basics, right? Many students don't know what does a function mean, what are the standard graphs for those functions, and what are a few standard functions, right? So we'll learn those. So let's start with first variables. So what do you mean by variables here? So a variable is an entity whose value is not fixed. So its value varies. That's why the name is variables. It can vary. Variables are generally denoted by letters x, y, and z. Okay. So here generally we denote it as x. So because x is very important. If you know what I mean by x. Okay. So variables are very important, right? Variables are things which we can vary. If you vary that, I am varying my input. Let's say I am varying my input. Let's say you are varying the speed of your car. You are inside a car, you're driving the car, right? And what happens? You press the accelerator knob, whatever you call that, I don't know. So you press the accelerator, right? Then what happens? The speed of the car is varying. Basically, you varied some parameter, you gave it some input, right? Okay, you gave it some input, then the speed also varied, increased, right? It gave you some output. So you're varying the input, and it is also varying the output. So basically you're varying the power consumption or whatever, right? There are many mechanisms inside a car, so that is varying. So that is what we mean by variation and variable. So you're varying x, and in the output we will get something. So what is the output? Output is basically this, right? We will understand that in the next few slides. So now let us define the types of variables. We have mainly three types of variables, right? So real variables. What are real variables? Real variables are if x and y is real variable, then x will vary from minus infinity to plus infinity, and y will vary from minus infinity to plus infinity. All of them should be real quantities. Okay, so I hope you understand what do you mean by real and complex numbers. Complex is basically another form, right, which is under root of -1. Okay, so when these are real, right, so they will only lie in the real domain. So x can vary from minus infinity to plus infinity, or y can vary from minus infinity to plus infinity. Now if we have vector variables, just the difference will be that my variables, right, will have some direction associated with it, right? So here x I cap, y j cap. So you have studied in physics what is I cap. I cap is in I cap direction, unit vector in the I cap direction, and j cap is the unit vector in the I j cap direction, right? So vector variables can be defined like this. Mainly we will work with the real variables in engineering mathematics, so you don't have to worry that much. Next is complex variables. So when we will study the complex chapter, right, complex calculus chapter or complex variable chapter, there we'll use complex variables. So this is vector variables. This is generally used in physics. Okay, here x and y component are there, and I and j are the directions of it. So you might say a car has velocity. If a car has velocity, it will obviously have magnitude of speed, right? Okay, it is moving, right? It is moving. Then in the x direction it will have some speed. In the y direction it will have some speed. In the z direction it will have some speed. We are in the 3D plane, right? Here all of this is in 3D. Also it will have some direction associated with it, because velocity means two things, magnitude and direction. So this is how we define the velocity of a car, right, with direction and magnitude. Okay, so we will need vector variables over there, right? Now what are complex variables? So complex variables are complex number, right? Complex numbers where we will have a real component and a imaginary component, a combination of real and imaginary component. Here also x is varying from this minus infinity to plus infinity, and y is also varying minus infinity to plus infinity. But z, right, z is a complex variable. It is very important to understand that z will be a complex variable. Okay, I'm just slowly giving you a few definitions. You already know all this, but still, like for the people who don't know, for the students who don't know, right? So what will be the topics that we'll cover in this whole calculus chapter? So this calculus chapter can be divided into two parts. One is differential calculus, another is integral calculus. Okay, so mainly we'll study calculus of real variables. There is another specific different chapter for complex variable. We'll study that later on. Okay, but obviously I'm going according to what are the most important. I forgot to tell you that this is also, or calculus is also almost for all the branches, right? All the branches. I hope you have watched my lecture 0 where I have told the syllabus for each of the main branches, right? Syllabus for each of the main branches. So this is limits, continuity, differentiability. Okay, in the differential calculus we'll study, then mean value theorem we'll study, Taylor series we'll study, application of derivative, that is AOD we'll study, then partial derivative. So these are the topics for differential calculus. Okay, I hope you have heard these names, or if you are in your college, so you must have studied all this, but there we don't have the concept clarity. We just simply solve the questions. We know the formulas, we just simply solve the questions. But what is the concept behind that? That also we have to understand, right? Yeah, mathematics is mostly about applying formulas and solving questions, but sometimes in GATE they may play with language. So mostly the questions from mathematics are asked generally easy, but sometimes they get asked difficult as well. Okay, and when they get asked difficult, no one is able to solve them. So you have to solve them also if you want to become a topper, right? So yeah, this is about the differential calculus. And what about the integral calculus? So in the integral calculus, basically we'll learn about the integration, right? So single integral, double integral, and triple integral. Okay, so first we'll cover this, then we'll cover this. Okay, so yeah, let's first understand what a function is, right? So what a function is defined as a relation between a set of inputs having one output each. So input must have at least one output. It cannot have two outputs. Input can have one output, cannot have two outputs. What do you mean by this? Here I have input, right, and here I have output. So if you press the accelerator of a car, then you should get a particular acceleration at the output, right? Or if I want to say, if you are changing your what do you say, steering wheel, right? If you're changing your steering wheel, let's say 30 degrees, so it should move only 30 degrees, or should move particular angle. If you change your steering wheel 30 degrees, and what happens, it moves 30 degrees on the right, and then again left, right and left. So obviously that is not possible. If you move your steering wheel 30 degrees, it will only move a particular direction and remain at that. Okay, and remain at that. That is, for a particular input, it is mapping to a particular output. It is not mapping to two outputs. If I move my steering wheel 30 degrees, the tires should move in the right angle, on the right 30 degrees, not 30 and 45. How can it move 30 and 45? It has to at least go to 30 degrees, right? So that is what this statement is telling us. Okay, trying to explain to us. So let's understand this visually here also. So let's say I have ABC inputs, right? Any function, I have a block over here. Right? Let me draw the block if I can. I have a block over here. If you have studied control systems for me, you will understand. Okay, if you have studied control systems for me, right, it will be added advantage for you, because there also I have taught you few mathematical concepts, so that will be used here. Okay, and yeah, so now basically what is happening over here, so this is the input and this is the output, right? This is the output, and here some function is there, that is the f of x function is there. Now if I give this input as a, x is equals to a, right? If I give this x is equal to a, it is giving me some output. Okay, I should not write this as xyz. I could have written this something else. What should I write this? That is what I'm thinking. What should I write this? I can write this d e f, right? So if I give input a, I am getting in the output d value. Basically, let's say if I rotating it by 30 degrees, it is rotating 20 degrees, because there is some other things, right? Exactly 30 degrees rotation won't give me 30 degrees rotation at the tires. Okay, so yeah, so it is giving me d. Now tell me, can this happen? If I'm rotating it 30 degrees, can it also give me f, let's say 45 degrees? Can it happen? No, right? It can't happen. It has to give me a single value. A single input has to give me a single value for a relation to be a function. Okay, a relation to be called a function, okay, it has to have, for a set of inputs, it has to have at least only one output each, right? So no, this is not possible. Okay, now for B, let's say I'm getting E. Now is this possible that for C also I'm getting E? Is this possible? Now read the statement again. Function is defined as a relation between a set of inputs having one output each. C has one output, fine. B has one output, fine. A has one output. Okay, so this is satisfying this statement, right? This is satisfying this statement. So this is a valid function. Okay, it doesn't necessarily mean that for another input I have to get different output. These both of this B and C can map to the same output. Okay, so a function, the mapping of a function can be called many to one or one to one also. Okay, mapping, let me write this over here in small letters. Mapping, basically I'm talking about mapping. Mapping basically is many to one or we can say one to one, right? What do you mean by many to one? So this you can look it up in Google. I will just explain this in briefly. Okay, in brief. So basically, what do you mean by many to one? Many to one means many inputs are mapping to single output. That is possible. A function, that is possible for a function. What does one to one mean? For each input, I am getting a specific output, not the same output again. So that is what one to one mapping means. So yeah, this is a brief talking about one to one and one to one mapping. You can just search it up. Relation. These are called also relation. Okay, you can look it up. Relations, right? In simpler words, a function is a relationship between inputs where each input is exactly related to one output. Exactly one output. It should be related, not two outputs, right? More than one output. Every function has a domain and a codomain or range. Okay, this is very important. Every function has a domain and codomain or a range. We'll understand these terms. A function is generally denoted by f of x, where x is the input. X is the input, and f of x basically is this block, and output is the y basically. Okay, so where x is the input, the general expression of a function is y equals to f of x. So output is y and input is x, and this f of x is the blocks that is basically manipulating the variables. X in our case is the independent variable to get a particular output y. Okay, so x is a variable over here because I am varying my x. Look, I am varying my x. My y is also varying, so y is also a variable, but there is a slight difference between these variable and that variable. This is the independent variable because I can give it any input. Obviously, it should lie in the domain. We'll understand what does domain mean, and output I will get according to the input. So output is dependent on the input. That's why it is called a dependent variable, and this is called independent variable. More on this later on. Let's understand this few basic terms. What do you mean by open and closed interval? So open interval and a closed interval are used to represent a range of numeric values. So it is basically used to represent range of numeric values, right? Whenever a range, so my input is varying from a to c continuously, so I can represent that with open and closed intervals. I will just give you an example and there you will understand. The open interval includes only the values between the endpoints and is represented as this normal round brackets. So they are called round brackets. Let me write this. Round brackets, and this closed interval, right? They are called okay. This is called open intervals. Wherever round brackets are there, they are called open intervals, and the closed interval includes even the endpoint of the range of values and is represented by square brackets. So this is called square brackets. Okay, so these are called square brackets. Okay, that is one thing. So now let me take a few examples. From there you will understand better. So let's say you have already seen this notation, so don't worry. I'm taking an example. So if I write something like this, x, this is a belongs to sign, right? Epsilon a comma b, and here I have round brackets. What does this mean? Let's read this statement. So the open interval includes only the values between the endpoints. Is only the values between the endpoints and is represented as round bracket. So it includes between the endpoints. So my x, this sign is belongs to. So I will explain the definition. This is belongs to. And here, what does this mean? This means that x lies between a and b, excluding excluding a comma b. Okay, so excluding a comma b, it lies between a and b. So basically if we have 1 comma 2, right, x will lie between 1 comma 2, between 1 and 2, 1.5 valid, 1.3 valid, right, but 1 is invalid. If something like this is written 1 comma 2 in round brackets 1, if I write x equal to 1, that will be invalid. X cannot be equals to 1. Okay, because it is excluding a and b. So I should write a and b. Now what about the second example? Second example is x belongs to, okay, I will not take the conventional one, I will take the different one. This is a comma b and this bracket, right, a comma b, this bracket. So can you tell me where does this x lie? Can you tell me again, right? This statement will be correct only. X lies between a and b. This statement is correct. Okay, but here I have to write two statements. So what will be included and what will be excluded? As you can see here, I have a square bracket. So if I have a square bracket, it will include the endpoints also. So square bracket on the right hand side only I don't have a square bracket on the left hand side. So it will include including this what do you say, including b, right, but excluding a, because x has a round bracket with it, right, x has a round bracket with it. So these two statements are very important, because anyways we know that a and b are written, so that will lie within the range, that is fine, but what is included and what is excluded, that is also very important to understand, right? So yeah, including b and excluding a. So this is the important point that I want to say about the difference between open interval and closed interval. So okay, so I hope you got this point, right? So yeah, if like this is given, so it will, x will lie between a and b, but it will not include a and b. Okay, but here if square bracket is given, so x will lie between a and b and it will also include b, right? It will also include b. Now what about the domain of a function? What do you mean by domain of a function? We just heard about this word, right, in the previous slides. So let's first read the definition. The set of all possible values which qualify as inputs to a function is known as domain of the function. So basically this set of all the possible values which qualify as inputs to a function is known as domain of the function. So it sometimes it may happen that I will not be able to give all the inputs to the function, right? Why? Can you rotate your steering like this and then again like this and then again like this, right? So like you have rotated already 360 degrees. I think there is some provision, right? After that you have to stop. So can you give it 400 degrees input? Can you give it that? No, the steering will break. The function will not work, right? So just like that here also, we can't give it any inputs, right? We have to stop somewhere. So obviously in steering wheel you stop in 360 degrees, right? Or I don't know, I haven't drove a car. I don't know, will I drive a car future? That also I don't know, but yeah, I like people who have already like driven a car, they will know, right? They will understand what I'm trying to explain. So there is some limitation, right? So that is what this limitation is talking about. So that is what this domain is. So we can't give any input to the function, so we have to define a range. So that range, how to represent the range, I've explained you, and why we can't give any inputs, that also I've explained you just now with an example. Okay, so it can also be defined as the entire set of possible values for independent variables, basically the x values, right? A domain of a function refers to all the values that can go into a function without resulting in undefined values. Because let's say in a car you give it 700 degrees input, the steering wheel, okay, you rotate it 700 degrees, what will happen to the car? Undefined, we don't know, right? Because it won't respond to anything, because the steering has already broken, okay, steering wheel has already gone broken, it has already been damaged, so we don't know what the car will give output. Okay, that's why it is known as undefined. So this is a visualization of this. So here, from here also you can understand it. So domain of x is basically 1 2 3 4 x, and like we are defining the domain by ourselves. Domain is something that we define by ourselves. If nothing is set, then obviously we will exclude those values which will give me undefined values. But if set like Generally we define the domain for ourselves, because for the steering wheel, what is the domain? 0 degree to 360 degree, right? So we can only rotate 0 to 360, we cannot rotate more than that. So we define it for ourselves. Okay, if nothing is set, we try to find out a domain whose for which inputs it gives me undefined values. What do you mean by undefined? Infinity, 1 over 0, all those things are undefined, right? You already know what are undefined values, I hope. So we'll also learn about those in the later chapters, like limits, in a much deeper manner, but for now I'm just giving you a brief about undefined values. Okay, so how to find the domain basically. Okay, you have already learned this, so let's go quickly through this. So domain of any polynomial linear quadratic cubic function is real, and domain of will be all real numbers, because anyways this, right? Let's say I'm taking an example. Okay, I'm taking an example, x square plus 2x plus 1, y equals x square plus 2x plus 1. So you can give it any values, right? It doesn't matter, any real value. Yeah, sorry for the interruption, actually the current went off. So as I was explaining here, right? So I have this function y equals to x square plus 2x plus 1. So what can I give input to this, right? What can I give input to this? I can give input anything, right? So x can be any value, negative, positive, it can be real number. So x can be any real number. So that's why the domain is any real numbers. Now, what is the domain of a square root? So I should add this in a second line. Domain of a square root. So domain of a square root function will be always that x has to be greater than 0. Okay, because I want my y to be real as well, right? Just hold on a second. Is everything fine? Yeah, I want my y to be real as well. So if I want my y to be real, that means that this domain has to be greater than 0. X has to be greater than 0, because if x is less than 0, it will become an imaginary number. Basically, under root of a negative number is imaginary number. We don't want that. We want our output to be real in this case, right? We want our output to be real. Okay, so that is the thing, that is the reason why x is greater than 3. So let me take an example. So this was the first example, so let me take another example, like y equals to under root x minus 3. Now can you tell me the domain here? So in this case, right, in this case my x belongs to minus infinity to plus infinity, all real values. Obviously I cannot never reach infinity, that's why this is round bracket, this is not square brackets, because I can never reach infinity, right? I can never reach infinity. What is infinity? We don't know. It is very high value. Okay, that's why these are round brackets. Whenever infinity is present, you will represent those with round brackets. Okay, now here, can you tell me what is the domain of this? So the domain of this will basically be x greater than 3, right? X any positive value, or x equals to or greater than 3. So x has to be equals to or greater than 3, right? X has to be equals to or greater than 3. Okay, so if x has to be equals to or greater than 3, what does this mean? This means that how can I represent this in the open interval and closed interval format? So here, right, x can be equals to 3, so I will include 3, and obviously infinity is there, but I can never touch infinity, so I will represent infinity with round brackets. So x be 2. If x is equals to 2, this will become minus 1, which is not possible, because my y is real, right? So for y to be real, x has to be greater than 3. That is the main important thing. So then domain of an exponential function is all real values. So e to the power x, a to the power x, right? A to the power x will be all real values. I am not going to that right now. Okay, so then domain of a logarithmic function is this. Domain of a rational function, y equal f(x), set the denominator not equal to 0. So let's take an example for a rational function. So if I take an example for a rational function, let me just go to the next page. So let me take that y equals to 2 by x minus 2, right? Y equals 2 by x minus 2. So if y is equals to x minus 2, then my denominator cannot go to 0. If my denominator goes to 0, okay, then it will become 2 by 0, which is undefined, right? Which is undefined. What is 2 by 0? We don't know. What is 2 by 0? You might say it is infinity. Okay, but we don't know, right? In the limits chapter, we'll understand this better. So it is 2 by 0. So basically, we never want our x to become that value which makes my denominator 0. So x cannot be equals to 2. So x should exclude 2. X can include any values. Okay, x can include any values, but should not include 2. So how you can represent this. Okay, how you can represent this? So either you can represent like this, that x belongs to all real numbers minus this particular value 2. You can represent like this, or what you can do is x belongs to basically from minus infinity to plus 2. Okay, from minus infinity to plus 2, but it cannot be equals to 2. It cannot be equals to 2. So obviously we have to put a square bracket over here, right? Then it includes, this is not union, this is intersection. Okay, no, not intersection, this is union. So basically union means this or this, right? Intersection means this and this. Okay, and or 2 to plus infinity. Okay, hence there are round brackets over here because this will not include 2. Okay, but it will include anything except 2. So that's why minus infinity to plus infinity we have, but just excluding these 2. So these both ways you can represent, right? So I'm not going too much into this because this will just waste our time. Okay, these are basics and I hope you're understanding these things. Now what is the range? The range of function is the set of all its output. Okay, basically whatever output I'm getting, that is the range, right? For particular inputs, right, which are in the domain. Okay, the range of a linear function is R. The range of a linear function is R. Okay, basically any linear function you can say y equals to x. Okay, it will be any real number, right? Any real number, y equals to x, y equals to 3x plus 1, y equals to 2x plus 1, anything, right? Okay, the range of a quadratic function y equals to, okay, this is actually, I should not have written this. This will be a square actually. This will be a square, right? Now where is it? Yeah, k is y greater than k, greater than equals to k if a is greater than 0 and y is less than equals if a is less than 0. So this is about the range. We will learn this in the quadratic graphical representation. From there we will understand. Okay, what is important? The range of a square root function will always be greater than equal to 0. This is important. This quadratic function we will already solve this in graphs. From there we will understand. So I gave you the previous example, right? Y equals to under root x minus 3. Okay, what is the range of this? This will always be positive. The square root function will always give me positive values. Okay, square root function always gives me positive values. Why is this the case? Because like many students get confused like this, that if my y square equals to x minus 3, I can write y as under root x minus 3. Okay, but they miss out on this plus minus sign. They miss out on this plus minus sign because this, right? Here in this case y can be negative as well. In this case y can be negative as well, right? But this, right, this cannot, x cannot be ever less than 3. X cannot be less than 3 because we have y square over here, and if this is a real number, so if we square that, we will always get some positive number. So x has to be greater than 3, right? X has to be greater than 3. That's why we did this, right? That's why we did this, that x has to be greater than equals to 3 because it has to be positive. Why it has to be positive? In this case, right, we're squaring a real number. Y is a real number, we're squaring it. So if you're squaring a real number, we should get a real number and positive real number. Okay, hence this has to be positive. For this to be positive, x has to be greater than 3. Now, yeah, sorry, again the light went off. Recording here is just so stressful. I'm really sorry about the interruptions. So basically now, right, so this, if I take the under root of this here, right, I will get both plus minus. Okay, that is the interesting fact. But I will obviously ignore the negative sign because here the function is like this, right? Function is like this. Okay, hence I will ignore the negative sign because y cannot be negative. So I will ignore the negative sign. Okay, I will ignore the negative sign because function is defined like this. Now, like this was just for showing you the example. Now what is the range? Range will be obviously always positive because x will be equals to 3 or greater than 3, right? So it can be like at minimum y can be 0. Okay, so my range of y, okay, range of y is basically, it will include 0. Okay, and it will obviously, it cannot include infinity, exclude infinity, right? So this will be my range of y. Okay, this will be my range of square root function. Okay, so you can check all this, right? Range of logarithm function, range of exponential function, you can do it for yourself. Okay, and for where denominator is like it's a rational function and denominator can go to 0, you can check the range for that as well. Okay, I won't do it, these are basic things, I won't go much into depth to this because this will just take more of our time. So here I have just given you a brief summary about domain, codomain and range. So what can go into a function is called a domain. What may possibly come out of the function is called codomain. What can possibly come out of function, not comes out of the function. Okay, what actually comes out of the function is called range. So for the particular domain what I am giving the input, okay, for the domain what is actually coming out of the function is known as range, right, which is actually coming out of function. Now what may possibly come out of the function is called codomain. What may possibly come out of the function, okay, this is a possibility and it is actually. So that is the difference between range and codomain. We haven't I haven't like taught you about codomain yet. So from here this examples we will understand what do you mean by codomain. So set of A is the domain. So what are the valid inputs I am able to get? Okay, set of B is the codomain. What are the outputs that I can possibly get? So this is set. So and like this, right, these are my range, these are my range. Sorry, here I've written something wrong. These are not 3 5, wait a second. My set of inputs is 1 2 3 4, set of codomain is 1 2 3 4 5 7, actually not up until 8. So yeah, this will be 7 only. Okay, and my this range, right, range will be 2 3 4 5, range will be 2 3 4 5, 2 3 4 5. Okay, so basically what do you mean by this? So if I have a function, right, if I have a function which is y equals to x plus 1, y equals to x plus 1. Okay, if I have function y equals to x plus 1, now what can happen? X can be anything, right? Here I have defined my domain as 1 2 3 4, but x can also take x equals to 0 as well, and for that I can get 1 as well. Okay, but my domain is defined, I have defined my domain like this 1 2 3 4. So for this particular domain what I am getting is 2 3 4 5. So these are my range as explained over here. So these are my range and this is my domain. Now for x equal to 0 I can get 1 as well, for x equal to 6 I can get 6 as 7 as well, all those things, right? So that is my codomain, that is my codomain in which I can give it some different values as well and I can get some different outputs as well. But currently my domain is defined like this, so I will take care of this. So if you are getting confused, don't worry, you have to just understand about domain and range. So you have been given this domain and for this particular domain I am getting this particular outputs. So these are the relations, right? So this will be my range and this will be my domain. That is the most important fact. Codomain, if you don't understand, you don't have to care about that. Codomain is just the extra part. What are the possible outputs I can get? So these are my all possible outputs that I can get. Okay, and many more, right? Codomain is all of this and range is this. Okay, so this is the basically difference between codomain, range and domain. Okay, now let's understand about dependent and independent variables. I have talked about this previously, so let's again try to understand this in a better manner. So y equals to fx. Y is a function of x. So y is dependent on x. Okay, whatever values x changes, y will change to some other value according to the relation between y and x. So x is called independent variable. We can assume any value for x independently within the domain of the function. Y is called dependent variable. Value of y is obtained after substituting the value of x in the function and hence depends on x. As we are substituting the value of x in the function and then we are finding the value of y, so y is dependent on x. Whatever value x can take, x can take any value and y will depend on that value of x. That is the basic difference of independent and dependent variables. Now let's learn about graphs. Okay, so basically the graph of y equals to f of x, where f is a function, consists of points whose coordinates are x and y. We already know all this. Satisfy x and y. Satisfy y equals to f of x. Actually, satisfy y equals to f of x. Not this. Y equals to f of x. Also, it is such that lines drawn parallel to the y-axis do not intersect the curve more than at one point. What does this statement mean? So this is known as a vertical line test. If you have studied in 11th, you will recall this. This is known as the vertical line test for a relation to be a proper function, right? For a relation to be a proper function. So basically, what do I mean by this? What do I mean by this? So as I explained at the start of the lecture, that the output, okay, basically for a particular input I will get a single output only. I can't get multiple outputs. So what is my input is in the x-axis. Generally the independent variable will be in the x-axis and the dependent variable will be in the y-axis. So this is known as y and this is known as x. Okay, and y is equals to f of x. Y is a function of x, that's why this is known as the dependent variable. Now basically these are my inputs, right? So for a particular input I should get only one output. For a particular input, if I am getting, like here also for a particular input I am getting a output here and here also, then it will not be a function, it will not be called a function. Okay, because I should get only one output. That's why what do? I take vertical lines, right? I take a vertical line, I take a line parallel to the y-axis or a perpendicular to the x-axis, and I go through each of these points, right? Each of these points, like this x1, x2, x3, and test those. So if my line, right, is only touching at a single point, if my line is only touching at a single point, okay, intersecting with the curve at a single point, then what can I say? I can say that yes, this is a proper function. Okay, this is a proper function. If it is touching more than one point, let's say it is touching here also and here also, then it is not called a function. Okay, it will not be called a function. Okay, so it has to only intersect at one point. Okay, intersect only once, then it will be called a proper function. We'll learn more about this in the later chapters also about this graph. So I just wanted to give you a brief about graphs. Okay, so like from here, can you tell me which are proper functions and which are not proper functions, like which cannot be a graphical representation of function? So this is the first question. Try to attempt this. How will you attempt? Try to use the vertical line test. So let me start. So in this circle, this is a circle. I hope you know the equation of circle: x square plus y square equals to 1. So you start going with the vertical line test. Okay, you start going with the vertical line test. What do you see? Like for this particular value of x, right, I'm getting two inputs. Okay, and for this particular value of x, I'm getting two inputs, which is not possible. Hence this cannot be a graphical representation of function, right? So this is not a proper function. Okay, we can write the equation x square plus y square equals to 1, that is fine, but this is not a proper function. This is not a proper function because for a single value of x I'm getting two outputs. Okay, now here, is this a proper function? If I go through this, right, I will always touch at a single point only. This is like a parabola, so this is a proper function. So this can be a graphical representation of a function. Okay, function and relation are different. X square plus y square equals to 1, that is okay, that is fine, but this will not be called a function, right? This will not be called a function. Okay, next is this c, right? See, if I apply the vertical line test, so this will again be wrong. Because I am touching my y-axis twice for this particular input. So again, this cannot represent a function. But what we can do, we can interchange the x and y, and from there you will see that I am getting this graph. So then this will be a proper function. So like I have to interchange my y and x. So in this case, right, what is the problem here? The problem is my x should be the dependent variable and y should be the independent variable. If I interchange those two things, then this will also be called a proper function. Okay, so it is also important that what is my dependent variable and what is my independent variable. Now let's go to the d, right? Let's go to the d. So here, like if like you may recall this function, this is a very famous function from your school days. So this is the greatest integer function, right? Greatest integer function. Okay, so greatest integer function is equals to, simply we will define this later on, is equals to n if my x is integer. If my x is integer, basically the n itself, and just hold on a second, and equals to n minus 1. Okay, if my x is not integer, right? Not integer, x is not integer. Okay, I will define this later on, don't worry. Greatest integer function, I will define this later on. So here, if I go through my vertical line test, is my line, right, vertical line touching the curve twice at any point of x? No, right? No. So this is a proper representation of a function. Here, if I go through this, what is happening? I'm touching here multiple points. For a single value of x, I'm getting multiple outputs. So this will not be a proper function. So again, this is not a correct representation of a function. So a, c and e will be my answers in this case. A, c and e will be my answers. Okay, AC and U will be my answers. Okay. So let's now learn about few standard functions of real variables. We're only talking about real variables right now, not complex variables. So we have algebraic and transcendental. So what are algebraic? Basically, algebraic involves only algebraic operations, addition, subtraction, division, all those things, right? Transcendentals are a bit different, like trigonometric. I hope you know what are trigonometric functions, right? Or exponential, or logarithmic, or inverse trigonometric. So here these are polynomial functions. So they are simply x square plus 2x plus 3, all those things. Then rational functions, x plus 1 divided by x minus 1, all those things, right? Then power functions, like k into a x raised to power a, something like that, right? Y equals to x raised to power a, something like that. So let me just give you examples here. Y equals to k x raised to power a. Rational will be something like x plus 1. So mainly we will talk about these functions, x plus 1 by x minus 1. Then polynomial is x square plus y equals to, these are all y equals, right? Y equals to x square plus 3x plus 1. Okay, so these are the case. Right? So here, right, transcendental will never be a polynomial, will not be a polynomial, not a polynomial, right? Not a polynomial. Okay. Can I write this better? I can definitely write this better. Not a polynomial, right? So it can be trigonometric, exponential, logarithmic, and inverse trigonometric graphs. So we'll like see the standard graphs, so there we'll understand. So before going to those standard graphs, right, I want to like tell you a few more definitions. So first one is even and odd functions. What do you mean by even and odd functions? Just hold on a second. Let me check everything is recording or not. Yeah, everything is recording. So what do we mean by even and odd functions? So basically, even function means let me just color these things, because this. Okay, how do I color these things? Just hold on a second. Now I can color. Not this. Yes. And odd function also have to color. Okay. So even function for a real valued function f of x, when the output value of f of minus x is same as f of x, then for all values of x in the domain of f, the function is said to be even function. So basically, what can be even function? Let me take an example over here. So if just hold on a second. If my y equals to x square, right? If my y is equals to x square. So if my y is equals to x square, that means what? If I do f of minus x, so y is f of x, right? So y is f of x. Just hold on a second. Equals to x square. Now if you replace x to be equals to minus x, what will happen? Minus x square. Minus x square means what? Minus 1 whole square is 1 only. So it will be again x square. So f of x will be equals to f of minus x. Hence it will be even function. Why? Because for the left hand side of my x axis, like in this graph, right, left hand side of my x axis and the right hand side of my x axis will be symmetrical. Okay, will be symmetrical, will be same. We'll see with examples. So this is the relationship. Now about the odd function. So if for a real valued function, if my f of x is equals to minus of f of minus x, then it will be called a odd function. So what will be the example of this? The example of this is simply y equals to f of x equals to x cube. Okay, or you can take x as well. So now if you replace x equals to minus x, what will happen? This will be minus x. So minus 1 times x. So it will be minus times f of x. Right, minus times f of x. F of minus x will be minus times f of x. Okay, so hence this will be called a odd function, right? So yeah, as x is equals to f of x only. Now this is the relationship. Now there is only one function which is both even and odd. What is that function? That is x equals to 0. So x equals to f of x equals to 0. F of x equals to 0 is a both even and odd function because it is always 0, right? It is always symmetrical. So for odd function, right, what do you call, we call it odd function is symmetrical about the origin, even function is symmetrical about the y-axis. Okay, y-axis. So odd function is symmetrical about the origin. So how can I write this? I can write this here in very short manner. About origin. Okay, and my even function is symmetrical oh no symmetrical about y-axis, right? About y-axis. Okay, this space is a bit cramped, but I hope you'll be able to understand this point. Okay, so a real valued function can be also neither even or not odd. So it doesn't necessarily mean a function has to be either even or odd. It can be neither even nor odd. So it is neither of those two things. So if it does not satisfy these two relations, if it does not satisfy these two relations, it will be called a neither even neither odd function, any or no. Okay, so what can be the example of that? So you can take the example of that as y equals to this 2 raised to power x, right? So if you take this example, right, y equals 2 raised to power x, if you plot this graph, right, you will see it is neither even neither odd, because if you replace x with minus x, it will be 2 raised to power minus x. Is there any relationship between this? No, it is basically 1 by f of x. So if I replace this, so just hold on a second. So if I replace this, right, with f of minus x, what will this become? This will become 2 raised to power minus x. So this will be 1 by 2 raised to power x. So if this is 1 by 2 raised to power x, this will be simply 1 by f of x, right? So this relationship is something different. Okay, this relationship is something different than this. These are satisfy these two equations. So here, like, I don't have space, so what I will try to cram in space here. So my y, so for the first case, right, my y is equals to f of x equals to, I give you an example, x square. So now if I replace this with f of minus x, what will happen? This is minus x square, not minus x square, this is minus x whole square, right? I'm replacing x with minus x. So this will become f of minus x will be simply equals to x square itself, which is equals to f of x, right? Which is equals to f of x. Hence this relationship is satisfied. Now if I use the second one, right, if I use the second one, so y is equals to f of x is equals to x, right? Simple x. So now if I replace x with minus x, what will happen? X, f of minus x is equals to minus x, right? So if it is equals to minus x, then what can we call this portion, right? This portion is f of x itself, right? So this will be f of minus x will be equals to minus of f of x, right? Minus sign is outside and this is f of x. So f of minus x is equals to f of minus x. Okay, so this is satisfied. This is satisfied. So yeah, so this is an odd function and this is an even function, right? This relationship is for even function and this relationship is for odd function, and for neither even neither odd, they won't follow this relationship, they will follow some other relationship. Okay, I've explained these two. So let's go to other definitions. So what is explicit and implicit function? So an explicit function is basically an algebraic function where the dependent variable can be explicitly expressed in terms of independent variable. It is an algebraic function. This thing you have to have a mind of. Okay, so don't worry, like, I'm telling you all these definitions, you might say, sir, like, these are so many definitions. Don't worry, just read these ones and that's it. These are very simple and fundamental things. Just hold on a second. These are very simple and fundamental things. You don't have to worry about this much, right? So just read these ones and these will come into your brain very easily, right? These are not that much of difficult things. Okay, so basically it is an algebraic function and it can be explicitly expressed in terms of independent variables. So after we study about the implicit function, there we'll understand like the difference between these two, actual meaning of this explicit function, right? So basically we haven't given this equation, right? Can I, like, my y, it is said that they have said that y is my independent variable. So why is the independent variable? So can I express my independent sorry, y is a dependent variable and x is independent variable. Can I express my y as a function of the independent variable? Can I do that? Okay, so let me try to manipulate this thing algebraically. So I can take y common over here, so this will be x minus 1, and I can take this this x, right, this and this on the right hand side, so this will be x plus 1. So this will become y equals to x plus 1 divided by x minus 1. Okay, so y equals to x plus 1 divided by x minus 1. Y equals to x plus 1 divided by x minus 1. Okay, so here my y is the independent variable. Okay, y is the independent variable, dependent variable, and my x, right, x is the independent variable. So I can easily express my dependent variable as a function of independent variable. Okay, okay, so this is why what y equals to f means. So now let's talk about the implicit functions. So from here we will understand the better meaning of explicit function. So implicit function is a function defined for differentiation of functions containing the variables which cannot be easily expressed in terms of y equals to fx. So here it can be expressed y equals to function of x, right? Here it cannot be. Can you explain? Can you separate these out, right? You can't, right? Simply you can't separate y, because here we have y square term and we have a y term. Okay, you cannot simply do that. It will be difficult. Okay, so here what we do, we simply write this like this, right? So we write this f of xy equals to 0. So this is known as an implicit function, where they are implicit to each other. They can't be separated. Y and x can't be easily separated, right? So, or sometimes they are represented like this phi of xy equals to 0. Whenever these types of things are given, right? So they are talking about implicit function. Okay, they're talking about implicit function. So implicit functions can have 3 variables also. So x square y square plus 3xyz plus z cube equals to 0. Okay, this can also be happen, right? This can also happen, minus 1 equals to 0. Okay, so here also I will represent my implicit function like phi of x y z equals to 0. Now why am I teaching you all this? Just so that you don't get surprised in the question paper if like some format like this comes up. If some format like this comes up, you will be able to understand that yes, this is an implicit function. I have already learned this, so you should not panic in the examination. That's why I am teaching you all this. Okay, so basically so this will be composite function. So what is composite function? Next is composite function. I've written this wrong. So like I hope you got the point, the difference between the implicit and implicit and explicit function. Explicit means I can explicitly represent my y as a function of x, right? I can explicitly represent that, right? But implicit function I cannot. Okay, so what is a composite function? The composite function is the composition of functions the composition of functions is the process of combining 2 or more functions into a single function. Okay, what do we mean by this? So here, right, this is an implicit function. They are 2 variables are independent and 1 is dependent. Now here what is happening, that composite function, in the case of composite function, let me take a function u, which is a function of x and y. Now the interesting fact about x and y is that my x, right, x is another function of t, y is another function of t, right? So y is another function of t. Okay, so just let me make these colors different. So x is another function of t, y is another function of t, right? So can I give you a practical example? Yes, right? So I'm moving in the x direction, I'm moving in the y direction. A car is moving in the x direction and the y direction. So it can be a function of time as well. That's why t is written over there. So in the x direction it is a function of time, and y direction it is a function of something, some other function of time. Okay, in the x and y direction. Okay, and the overall x and y, right? Overall x and y, I can write in terms of a function u. Okay, so if I write my u is equals to x square plus 2y. Okay, if I write my u is equals to x square plus 2y, then I can represent this in terms of single variable as well, right? Okay, u can be written like a function of g of t as well, right? You can be written like g of t. Basically, sorry, you can be written like this okay, I'm sorry, I should write this like this. This is a phi of t, sorry, phi of t only. So like x and y both are functions of t itself. So I can write my u as, just hold on a second, this is f only, right, as a function of this, right. I can write like this is known as a composite function inside a function, or this is also represented like this, f of fog. Okay, generally like this is g of t only, so I should represent this in g actually, like that is the normal terminology. So this is g of t, this is g of t, and it is written f of fog of t. Okay, okay, so they can write like this also, they can write like this also, this is g, this will be g only. Okay, so yeah, this is the case basically. So I hope you got the point, right? So basically my x and y can be anything, my x and y can be anything. So x can be simply equals to t, y can be simply equals to minus t, right? It can be anything. Now here I can write my u as t square minus 2t. So I can directly write my u as a function of time instead of writing it in terms of x and y. Sometimes this is helpful. Okay, sometimes I want to know this x and y. Okay, sometimes this is helpful. So you have to know both ways, right? So this is what a composite function means. Basically combining two or more functions into a single function. Here I combined this into a single function, right? Here this x was a function of t, this y was a function of t. I combined these two into a single function. Okay, that is the basic meaning of composite function. So all these are done. Okay, basic definitions, don't have to go too much into this, just lightly study all this. Okay, next is some standard curves. So we have to see some standard curves. You have already, I hope you have already learned all this. Okay, if you have forgotten, you can quickly watch these two. So the first one is the most simplest one, is y equals to x, which is the linear line, right? Linear, y equals to x. So it's simply a straight line. Okay, and like there are many parameters of this, like the slope one. Okay, what is the slope of this? The slope of this is 1, right? How do you find out the slope? You find out the slope from here, right? Whatever coefficient this x term has, so that will be the slope. Like slope means how fast I am changing, as I am moving forward, how fast I am changing. So this is the slope. The rate of change will be constant. This is basically the differentiation, right, of the curve. Okay, so this is our slope. What is the y-intercept? The y-intercept is x equals to 0. Here we don't have plus c, so that's why y-intercept is x equal to 0. So that is one important point about y-intercept and slope. So for a straight line, you have to understand only the slope and y-intercept. So I have already taken the example, right, previously, that this will be a odd function. This will be a odd function, right? Odd function. So why this is symmetric? If you see it graphically, this is symmetrical about the origin. This is symmetrical, right? Symmetrical about the origin. Okay, so if you break this down, right, this will be symmetrical about the origin. This portion and this portion are same. Okay, or if you want to prove it from the what function, that relation, I've already done it mathematically. Now let's go to the second graph, that is f of x equals to x square. So f of x equals to x square, it is a parabola basically. Don't go into my drawing, so my drawing is not that much good. I will try to make this better actually. Just hold on a second. Try to make this better. Yeah, this is much better. Okay, so this is a parabola basically. This is a parabola. Okay, so basically what is this? This is y equals to x square, right? Y equals to x square. F of x equals to x square, y equals to x square. Now here what do you see? It is symmetrical around the y-axis, so this will be even function. This will be a even function, right? Graphically also you can understand. Okay, now here, right, my y is always positive. Because I'm squaring a real number. If I'm squaring a real number, y cannot never be equals to less than 0. So range of y will be always positive. X has domain of minus infinity to plus infinity, but range of y will always be positive. We'll ignore the negative sign, right? We'll ignore the negative sign. Okay, so that is another important point. So basically domain of f of x is basically x belongs to minus infinity to plus infinity, and the range of f of x, the output that I am getting, right, the output that I am getting is equals to y. Basically y can be only positive values, it can be 0. Okay, it can be it cannot be non-negative values, sorry, it can only be non-negative values. So non-negative includes 0 as well. Positive does not positive is not included, like 0 is not included in positive numbers. That is also another important fact. So infinity, right? So yeah, this is my range of f of x and this is my domain of f of x. No further discussion on this. So let's go to the cubic, right? So f of x is cubic, so my graph will look something like this for a cubic function. Okay, so why is it like this? So basically it was like this only, but for a cubic, right, it is an odd function. Like if you replace x with minus x, you will see it is an odd function, it is satisfying the odd relationship. That's why it will be symmetrical about origin and not about y-axis. Okay, so that's why this thing, right, doesn't come up here, this thing comes up here in symmetric about origin part. So y is equals to x cube. Okay, and this is the odd function. You can prove it for yourself, you can prove it for yourself. Okay, so next is basically this rectangular hyperbola, right? If you see y equals to this 1 by x, so y is equals to 1 by x. Now if I replace this, right, I can do one thing, x, I can like manipulate the variables. My x and y will be equals to 1 itself, x and y will be equals to 1, right? So my x and y is equals to 1. So this is also called as a rectangular hyperbola. It is also called as a rectangular hyperbola. Okay, this is also called as a rectangular hyperbola. So this is called a rectangular hyperbola. Now the shape is something like this. The shape is something like this. At x equals to 1, at x equals to 1, y should be also equals to 1, because if I put x equals to 1, y has to be equals to 1. If I put x equals to minus 1, y has to be also equals to minus 1. Okay, because minus 1 into minus 1 will be 1. In these 2 points only, they will be equals to 1, but the product of them will be always 1. So basically as my x is increasing, right, as my x is increasing, y has to reduce. That's why y has reduced. As my y is increasing, x has to reduce, right, because the product of x and y are constant. Okay, so basically like they are going towards infinity. Here also they are going towards infinity. So there is one special name, that is the asymptotes. So asymptotes basically touch the curve at extreme points. These are lines, these are straight lines. I should write this lines. Let me do one thing. Okay, basically these are lines that touch the curve that touch the curve at extreme points. These are lines that touch the curve at extreme points. Okay, so what are the asymptotes of this? So the asymptotes will be something like this. So the asymptotes I am drawing here. Okay, basically these are my asymptotes, right? These are my asymptotes, because what are the extreme points? Extreme points are this minus infinity, x equals to minus infinity, y equals to infinity, x equals to what? X equals to infinity. Okay, just x equals to, hold on a second, yeah, x equals to infinity and y equals to infinity. Now in this case, right, my what is the equation of my asymptotic line? Equation of asymptotic line will be something different, right? So equation of asymptotic line will be something different. As it is tending towards 0, right, it will obviously tend towards 0. Okay, obviously it tends towards 0. Hence this line, right, the equation of this line will be what? The equation of this line will be y equals to 0, and the equation of this line will be x equals to 0, because at x equals to 0, like it will almost touch my x and y axis. So asymptotes in this case are my x and y axis, right? Okay, so in this case asymptotes are my x and y axis, because as I keep on increasing my x, y as my x is going towards plus positive infinity, my y will go towards negative infinity, right? So 0, y will go to 0, because the product of those two has to be 1. So if my x is 500, y has to be 1 by 500. X is 1000, y has to be 1 by 1000. X is 10,000, y has to be 1 by 10,000. You can see, right, y is reducing, going to a 0, okay, going to a 0, and x is increasing very high. So you can relate like that. So asymptotes in this case, right, asymptotes are my x and y axis, okay, x and y axis, right. So also one more thing to notice about this is just after this 0, right, like this is going to infinity plus infinity, just after this is a 0, like x equal to 0 line, right. So just after this my y is f of x is positive infinity, just before this my f of x is minus infinity. So what can we interpret from this? There are many things we will be able to interpret in the limits chapter. So just wanted to give you a sneak peek of this, that f of 0 plus, right, just after 0, this is, we're going into transient now, so just after 0 this is going towards plus infinity, okay. So f of x is plus infinity. Now just before 0 this is going towards negative infinity, okay. Just before 0 this is going towards negative infinity, right? Negative infinity and positive infinity. So these two the other things. So like these two, right, these two are not equal. What does this signify? We'll understand it is in the limits chapter. So f of 0 plus is not equals to f of 0 minus. So what does this signify? We'll understand in the limits chapter. So here also this is some different relationship. This is like the f of x equals to 1 by x square. So we have 1 by x square, so this relationship will be like this, and here basically my asymptotic lines will be only this, right. These are my asymptotic lines, x equals to 0. So this is also tending towards y equals to positive infinity, this is also tending towards y equals to positive infinity, and here, right, this is tending towards x equals to negative and positive. Anyways, we're going through all of this x axis. So here what is the interesting fact? The interesting fact is just after x equals to 0, this is my function is tending towards positive infinity. So I can write that f of 0 plus is positive infinity, right. I should write it like this. This is tending, right, this is tending, this is tending, like equals to infinity, something else. So okay, fine. So we can, anyways, okay, we shouldn't write tending, we can write this equals to, anyways, okay, we can write this equals to, no worries. So this equals to positive infinity, and just before this, right, just before this f of 0 minus will be simply positive infinity again. F of 0 minus will be simply positive infinity again. So this is also positive infinity, this is also positive infinity. So these two are equal, okay, these two are equal. So this, if these two are equal, what does this signify? We'll understand this in the limits chapter, okay. So we will understand the limits chapter. So 0 minus is here, some neighborhood of 0. 0 minus and 0 plus are the neighborhood of 0. So this is 0 minus and this is 0 plus, right. So this is also 0 minus and 0 plus, just the neighborhood of 0, and the neighborhood of 0 is very important to us. Why? We'll understand. So one key point I want to say is that if something is like this, right, that y is x raised to power m, x raised to power m means this, right, okay, and then y equals to x, this is a linear function, and y is x raised to power 1 by m. This is basically the square root function. We haven't done the square root function. So in the next example I will take to compare all the three, right. This is like example of square root function if m is equals to 2, if m is equals to 2. So in this case, right, so m has to be integer, that is the first thing. M has to be integer, m has to be integer. So if m is integer, okay, so if m is integer, and also m has to be greater than equal to 2, because m equals to 1 doesn't like make sense, because it is simply the linear line itself. So m has to be greater than equals to 2, okay. So m has to be greater than equals to 2. So this is the first thing. So basically if m is equals to 2, that means this is a square root function, and my graph for a square root function will look something like this. Graph for a parabolic function will look something like this, right, quadratic equation you can say, and all of them will meet at 1, because square root of 1 is 1, so 1 square is 1, okay. But what are we observing here? So as my as my x is lying between 0 to 1, it will be something lower than 1. Why is that the case? So let m equals to 2. Let m equals to 2. So if m is equals to 2, what does that mean? That means that my y equals to x square. Now y equals to x square. If I pick any number between 0 to, just hold on a second, 0 to 1. So if I pick any number between 0 to 1, let me pick 0.1. So if I pick 0.1, what is the square of this? This will be 0.01. So y is even lower than that. Y is even lower than x. So always it will be lower than the whatever I chosen, right? At 1 it will compensate almost. Okay, at 1 it will almost compensate. So it will always be less than the straight line. Y will always be less than x. So it cannot cross this line, right? It will be always less than this, right? That is the first thing. Next, let's take the example of a square root function. Square root function. Y is 1 by 2, right? 1 by 2. So let me take a simple square root function. So if I take x equals to 0.01, 0.01, and I am taking the square root of that. What will the square root of that? The square root of that will be simply 0.1, right? So if you take the square of this 0.1, you will get 0.01. If you take the square root of this, you will get 0.1. I hope you got the point. Now I am getting 0.1, which is basically greater than x. Whatever x I have chosen, which is greater than x. That's why this is over this x equals to y equals to x line. So that's why my square root function will always be over this y equals to x line, and this square function will always be lower than this x equals to y, y equals to x line. But after 1, everything changes. So after 1, what will happen? 2 square will be 4, 4 square will be 16. So obviously my x is like y is greater than x always. So this, right, this will always lie above the y equals to x line. Now in this case, right, what is happening? In this case, basically I can say that under root of 4 is what? 2. So it is lower. What I have chosen x as 4, but it is lower than my x 2, right? So that's why this will be always lower than my y equals to x line. So this is how we generate the curves. And for higher order, same thing, same relationship follows, just the numbers are different. Okay, so like this was just an intuition that I wanted to give, right? So another key point I wanted to explain is that we already know this. If you don't know, then please know, okay, that under root of -1 is plus of under root of -1, which is iota, right? Which is iota. I hope you already know this. Now under root of -1 1/3, under root of -1/3 is cube root of -1, which is minus or 1 itself. It has other two solutions as well. It has two solutions. Okay, basically this, right, this is also like two solutions, which is plus minus iota, right? So because if I square minus iota, that will also yield me -1, but we will only take this positive value, okay, in our case. Okay, next is this -1. So this has three solutions, because whenever I am doing cube root, right, this has three solutions. This is also known as cube root of unity. If you recall that it was equals to 1 plus omega square equals to 0. If you recall correctly, that was cube root of unity. But in our case, up in this chapter, we will only stick with real values. Hence, this will be equals to -1. Okay, and this will be equals to iota and not minus iota. Okay, so these two things, I hope you got clear, right? I hope you got clear. Okay, so like how to solve this? Basically you can solve this using this, right, that x square plus 1 equals to 0. So x will be equals to plus minus under root 1. Okay, so here x is equals to plus minus under root 1, but I am only concerned about plus under root 1. That's why I will pick only iota. I will pick only plus I. Okay, and here how you will solve this? So here if you solve this, right, like this is cube, right? This is cube. So I will write x cube plus, sorry, this is -1. This is plus 1 equals to 0. Now if you take the square root of this, obviously you will get three solutions. I will only choose one, that is -1, because we are sticking with only the real solution, right? So we ignore the imaginary solution. So here let's go to this graph, right? X under root. So I first explain this to make you understand the under root graph. So this will be like this only. It will obviously be initially higher than the y equals to x curve, then it will be lower than the y equals to x curve, right? Then from here what you can understand is that y equals to x square is a even function, that we know, right? Y equals to x square is a even function. Okay, y equals to x square is a even function. Then y equals to x is is basically a odd function. Y equals to x is an odd function because it extends up to here as well. It extends up to here as well. But one thing to notice here is that x cannot extend, right? Sorry, this function, right? This blue function cannot extend in the negative values of x because domain of x is greater than 0 only. Okay, x can be greater than equal to 0 only. Okay, it can be only greater than equal to 0 only, right? So yeah, this is the case. So basically it is neither odd neither even. Okay, I have got the point. This is neither odd neither even. So this is another example of neither odd neither even, right? So this will be neither even neither odd. Okay, so I have got the point, right? So like here I have plotted for x equals to like y equals to cube root, right? Cube root of x. Okay, y equals to cube root of x. So here I've compared this with x cube and y equals to x 1 by 3. So as you can see, these are always like some symmetry is there, right? Some symmetry is there always. So as I this is what I was trying to explain here. There will be some symmetry between the y equals to x raised to power m and y equals to x raised to power 1 by m. Okay, and this obviously straight line y equals to x. So here what is happening is that obviously this is the same reason why this is below and this is above the y equals to x line, the same reasons, right? But here also same reason. So this will also be like, this is an odd function, right? This is an odd function, so obviously this will be similar to this only, but this will be symmetrical to the origin. Okay, and this will be this. So you can calculate this in graphs and you can understand this, right? I'm not trying to explain anything. So basically at -1, right, these will be equal because cube root of -1 is -1, because -1 into -1 into -1 is -1, -1 into -1 1, then into -1 again is -1. So this will be -1. Okay, and yeah, this will be this, and they will meet at this. So like you can understand, right? All these graphs you can just put it in the calculator and you can calculate, right? You can observe the relationships. So I was just trying to explain you the symmetry. So this x raised to power y equals to x raised to power 1 by 3, right? This can take in negative values. Square root cannot take in negative values, but this can take in negative values. So hence, what does this become? What type of graph is this? This is a odd graph. So this is a odd graph, right? Because x of minus like f of minus x equals to minus f of x, because if I replace this with minus x, so f of x equals to x raised to power 1 by 3, right? Now if I replace f of minus x, right, x with minus x, so this will become minus x 1 by 3, and this will be minus 1 by 3 x of 1 by 3. So what is like cube root of -1? It is -1 itself, right? It is -1 itself. So I will simply replace this with -1, and what is x raised to power 1 by 3? X raised to power 1 by 3 is f of x, so it will be f of x only. Okay, so f of minus x equals to f of minus x minus f of x. That means this is an odd function, so that's why I have written this is an odd graph. So this has already been proved, so this will also be odd graph, right? So -1 cube is -1 itself. So this will also be odd graph. So this is also odd. Okay, so next is we have to plot the quadratic equations. So before plotting that quadratic equation, we have to understand what a quadratic equation is. We already know this, like f of x equals to x square plus bx plus c. This was with us, I think, from class 5 or 2. Just hold on a second, let me turn on one thing. Actually the currents were going so frequently that I forgot to turn on one of the lights. Okay, so anyways, without lights also I look good, I hope. Okay, or you guys can say in the comments. So y equals to f of x equals to ax square plus bx plus c. This is a quadratic equation. Now in this case, if my a is greater than 0, it will be concave upwards. What do you mean by concave upwards? It will be something like this. Shape is concave, right? Concave means like some cave shape, right? Cave shape. So in like hilly areas, you know what a cave is like. Bears stay there, make their own what do you call, IGNU or something, I forgot the names. So they make their own cave. So this is concave up. So this is like, this shape is known as concave up. Okay, up. And this is known as concave down. Okay, down. So you just try to remember that concave down means this and concave up means this. Slowly you find some analogy, and from there you will be able to understand. Okay, so for a greater than 0, it is concave upward. So it is always upwards, right? Going, touching plus infinity, plus infinity. Y is touching plus infinity. That's why we call it upwards. Downwards mean minus infinity. So which place you want to become? You want to go upwards or downwards? We all of us want to go upwards, right? So that's why concave upwards plus infinity. Concave downwards, we don't want to go down, minus infinity. Like this you can remember. Okay, so and these are what, alpha, beta, or what are the roots where my y value has become 0. Okay, y value is becoming 0 for particular x values, right? So alpha, beta, and roots, and I have given you the explanation. And the root side from the Sridhar Acharya formula is this side. Now this is known as the discriminant. This b square minus 4ac is known as the discriminant. And if d is greater than 0, my roots will be real and distinct roots. If d is equals to 0, my roots will be real and equal roots. If d is less than 0, roots will be complex or no real roots. Okay, no real roots. Roots will be complex because they will never touch the x-axis. They will never touch the x-axis. Okay, then my discriminant will be less than 0. Okay, I won't have a real root. I have taken the first case where discriminant is greater than 0. That is, I will always get real and unequal roots. Real and unequal roots. This we have already studied in the control systems chapter. Okay, in the time response chapter. For zeta, right? If you recall, for zeta. So real and distinct roots I am getting, and this is touching my x-axis, but for a greater than 0 and less than 0. Then if my d is equals to 0, if my d is equals to 0, I will get real and equal roots. So I will get only one root, and like basically equal roots. I will get two roots always, but those are equal. So I will see only one root over here, and they will be touching my x-axis here, right? So yeah, and this is concave upwards and concave downwards. Now again here, right, if my d is less than 0, it can never touch the x-axis because I don't have any real values of x. This line, right, represents all the real values of x. I don't have any real values of x, so this will never touch this. Okay, so if this never touches this, so this will be either here and here, right? These are the possibilities. Also this can be here as well. This can be here as well. Okay, this can be here as well. This can touch the y-axis as well, like x can become 0 as well. That is a possibility. Okay, but the broader picture, I hope you got the understanding, right? So again, this is concave upwards and concave downwards, negative infinity and positive infinity. Okay, so like now let's come to the conic sections. So these are similar only, the same things only, just we are doing quick recapitulation of whatever we learned. So we haven't learned this, right? Y square equals to 4x. Okay, I told you, right? I told you in one of the examples for the graphical representation, this can't be a proper function because if this is the dependent variable and this is the independent variable, we are seeing that it is touching twice. Okay, but we can write the relationship, right? We can write a relationship because sometimes you have to make the relationships work. Okay, even though you have difficulties. So basically in this case, right, what I have assumed is that a is positive. In this case, a is positive, right? A is positive. Just hold on. Also my x has to be positive in this case. X also has to be positive because y square is a real number, right? Okay, I have already written this. A is positive, so y square is already real number, so x has to be positive because y square has to be always positive because it is a real number, right? It is a real number, so minus 1 whole square is 1 itself, so it will also has to be positive. So that's why I'm saying that I'm always lying in the right hand side of my x-axis, right, for all positive values of x. Okay, so this is the case, and this is y equals to again 4x, right? This time the difference is that my a is negative. So if my a is negative, then my x has to also become negative, right? X has to also become negative, right? If my a is negative, x has to also become negative. Okay, so x has to also become negative. That means I will always lie in this left hand side, right? Left hand side. Okay, so okay, what am I doing wrong? So this will be only, this will not be negative, this will be plus a only, this will be plus a only. Okay, so yeah, you can either write it like this Or another way you can write, okay, another way to represent this is, let me take this, okay, not this, this. You can write y square equals to minus 4ax and a is positive. Okay, you can represent it like this also. Then also my x has to be obviously negative, right? X has to be negative. So either way, both way works. Both way works. Okay. So the interesting thing is that always it will lie on the left hand side, because y square has to be positive. Y square has to be positive. Y can be negative. Y can be negative because minus 1 whole square is 1. So minus 1 is negative, but the resultant square is positive. So y square has to be positive. So this whole quantity has to be positive. So if a is negative, then x has to also be negative. That's why I made it like this. So a is negative. So don't get confused. This confuse it as positive. This is a is minus 1 minus 2. This is negative. That's why it is lying over here. So what is a comma 0? Basically, when my y is 0. So when my y is 0, basically this is a vertex, so don't get confused. This is something something else, so you don't have to worry about this right now. Okay, then you don't have to worry about this. This is like the few terminologies about the conic sections. We don't need to study all that. Okay, those things are not required for game. Okay, so this is about the parabola. We have different type of parabolas also. This parabolas, right? So this is like x square equals to 4ay. This is like y equals to x square, like that. So we have already studied that. So here a is again positive. So if a is positive, this is something like this, x square equals to 4ay. Now in this case, right, like my x square has to be always positive. X square has to be always positive. So if x square has to be always positive and a is positive, so y also has to be always positive. That's why I am always lying above the x-axis, above the x-axis. Okay, here my x square is equals to minus 4ay. Okay, so x square has to be positive. Now a is a positive quantity, like you can assume anything. Okay, you can assume anything, but here I am assuming a is a positive quantity. So if a is a positive quantity, y has to be negative. So to make this overall positive, so that's why I'm always lying below the always lying below the x-axis. Okay, in this case y has to be greater than 0. Okay, so I have got the point. Again, like you can choose, you can write like this, that x square equals to plus 4ay, where a is negative. You already assume that a is negative, then also y has to be negative. Okay, you can do it like that also, whatever suits you. Now next conic section is ellipse. Okay, what are ellipse? It is related like this, that x square by a square plus y square by b square equals to 1, where a square is greater than b square. That is very important. A square is greater than b square. If a square is greater than b square, my major axis will be x and minor axis will be y. Okay, like you can remember like this, a is greater than b, that is the x denominator is greater than the y denominator. Hence my major axis will be my x axis and minor axis will be my y axis, and the diameter of the major axis is 2a and diameter of the minor axis is 2a. Okay, and this is known as ellipse. Now if my a is equals to b, right, if a is equals to b, what shape we get? We get a circle, right? We get a circle. We get a circle. Okay, so yeah, this is what we get. Next, let me go to another ellipse. So this time, right, my b square is greater than a square. Basically the denominator of b square is greater than a square. That means it will be, the major axis will be y axis and minor axis will be the x axis. Okay, so yeah, this is basically for ellipse. I'm going a bit fast because these are not that important, just revising a few things. Okay, again, this rectangular hyperbola, right, if there is a minus sign instead of a plus sign here, this will become a rectangular hyperbola. We have other variations as well, like y equals to 1 by x. That was also another variation. We have already learned that. Okay, so from here, this is a even function. Is this a even function? This already ellipse, right? This already ellipse. So this is symmetrical about y axis. So we can say this as even function. Here also we can say this as even function. Okay, you can say this as even function because what is happening? If I put x equals to a, this will be cancelled out and y will be equals to 0. So we'll start from here and go towards infinity. Okay, why we are going towards infinity? Because if I make x infinity, right, if I make x infinity, what will happen? Let me do one thing. So x is very high, right? X is tending towards infinity. So I can write this function as y square by b square equals to 1, just hold on a second, x square by a square minus 1. So if x is very high, right, tending towards infinity, this one doesn't matter. Okay, this one doesn't matter. X is very high, so I can ignore this one. So basically, my y square by b square will simply be equals to x square by a square, right? So now what can I do? I can take the under root, right? I can take the under root. So my x is going towards infinity, my y will also go towards infinity itself. Okay, let me just show you. I can take the under root, right? So this will be plus minus b by a into x. So if x is going towards infinity, y will also go towards infinity, but it will depend, right? It can go towards negative infinity as well, positive infinity as well. Now what are the asymptotes in this case? What are the asymptotes? So the asymptotes, okay, asymptotes are something like this, right? This line and this line. What are these lines? Can you represent this in terms of equations? Yes, we can. So here these are the asymptotes, right? What are asymptotes? Towards the extremums, towards the extreme points. Extreme points means what? Where my x is tending towards infinity. So this is basically I like derive the equation here basically. So this is already written over here, asymptotes. So that's how this came, right, from this derivation. So here basically what is this line? This line is y equals to b by a x, right? Simple straight line, right? Simple linear straight line. Okay, the slope is just different in this case. And what is this line? This line is y equals to minus b by a x. The slope is negative because this is reducing instead of being increasing. Okay, so I hope you know basis of slope and differentiation, all those things. I hope you know, right? So yeah, that is what my slope is. Okay, and like that is what my equation of asymptotes is, right? So this is the derivation of asymptotes. You just tend x tending to infinity, and then you find the value of y, and from there you will be able to find the equation of the asymptotes, right? Okay, so yeah, that was the derivation. Now just before going to a function, okay, mod function, I haven't taught you the mod function yet, so that is one important thing. Okay, actually basically these are the ends of the conic section, and I forgot to put the modulus function here. Modulus function will be taught in the next lecture. So if you know a bit about modulus function, you can plot this function, right? So first what you do, try to plot this, right? Then you try to plot this modulus of this. If you know already this, if you already know this, that will be good, right? That will be good. 2x minus 1 mod. Okay, okay. So this is what this is. So f of x is 2x minus 1 and f of x is x into x plus 1. So you try to plot these three functions, and in the next lecture I will start with these questions and more graphs, and then more about functions, more standard functions, and will end the topic of functions and graphs. Okay, so I hope to see you in the next lecture.